So this demo is going to demonstrate how the new NGL VAO factories work and how we can create vertex array objects within NGL. So what we have here is a very simple void shape that's been generated by a series of vertices, and we're calculating the normals. And we're going to use the built-in simpleVAO, which is a single buffered vertex array object for a unique pointer of type NGL abstract VAO, which is obviously the base class for all of them. We're using a unique pointer because the unique pointer will call the destructor when we're finished, and all of the VAOs will clear up the OpenGL buffers when they're destroyed. And the main class that we're interested in is the build VAOs. This must be called in initializeGL because we need a valid OpenGL context to be able to create our vertex array objects and obviously load buffers and things like that. So I'm going to start with a stud vector of NGL vec3s, and each one of these is a triple of vertices that are specifying one of the four triangles for the void shape. So we've got a nice stacked array of contiguous vertices here. After that, I'm going to use the NGL calc normal function. All this does is it will take in 3 points, it will subtract each of the points to get a vector, take the cross product, which will then return the normal, and I'm going to add to the end of this the per vertex normals. You can see each face has the same normal, so we've got the 4 sets of vertex normals there as well. So what we've got is a contiguous array which is going to be XYZ, XYZ, XYZ for all of the triangles, followed by the XYZ for all of the per vertex normals. Next, we're going to make a call to the VAOFactory create VAO, and what this does is it will call one of the pre-registered creators. You can see when NGL starts, there's a list of 3 creators that come as default. We can then go on, as I'll show in a later video, to create our own to extend how NGL deals with vertex array objects. So this will return a VAO, an abstract VAO. In this case, I'm saying use the create method for simpleVAO, and we want to initially start by drawing triangles. We must then ensure that we bind the VAO. If we don't do that, there will be no active vertex array object to associate subsequent buffers to, so all the data will just basically disappear. Next, we're going to call the setData method, and setData is passed in this simpleVAO vertex structure. In this case, this is actually just the abstract structure, and this will basically just be passed in a size, which is the size in bytes for our data, a pointer to float data here, which is just basically just being passed through, and the draw mode. So this is basically what we would pass to the GL buffer data command to copy our buffer data across. So in this case, I have to specify in bytes how big our data is. So I'm saying that it's the size of the stud vector multiplied by the size of the elements in this case. So this will give us our size in bytes of data, and then this is the first element of that data. OpenGL will now copy this into a buffer, and the simple VAO will, if there's no buffer present, create a new buffer and copy the data. If there is already a buffer present, it will delete that buffer and create a new buffer. So this is a very simple one-off buffer. So it can be used for recreating data. Again, I will show this in another example. Now the data's been passed through, we need to set our generic vertex attributes which correspond to the data in the shader. So in this case, I'm using a layout where my location 0 is the input vertex and my location 2 is my input normal. So I need to associate these now. So this is similar to calling the GL vertex attribute pointer function, and the parameters are the same. So I'm saying that my first generic vertex attribute, 0, has three elements of type GL float, and the data starts at the beginning of the array, and the stride is 0. So basically the data is tightly packed. So we're just going through each time. My next one is saying that my input is 2. So the input of the generic vertex attribute is 2. There are 3 elements again of type GL float. The data is at the beginning, and it starts offset 12 times 3. So that's basically pointing to the next chunk in the array for the data. Finally, we need to say how many indices there are. In this case, calling size will give the size of the entire array, and we only want half of it. I could just hardcode 12 in there and it would work, but in this case I've done verts.size divided by 2. And then finally we unbind because we finished. We may be setting some other VAOs. In this case we're not, but it's always best to unbind when we finish setting data. To draw, we now only have to issue 3 commands because the vertex array object will remember all of the OpenGL state. So we say bind this current VAO, draw, which we'll then call draw, unbind when we finished. Again, in this case we would only need to bind once and unbind, but it's always best to do this. It won't add too much performance in this case. So that is our very simple VAO demo. The next videos will show the different types of buffers and how we can change things.